Hello, I'm Melissa Illingworth. This is my video about doing calculations with the density of a metallic crystal. So in this question, we know the metal is chromium. We also know that it's a body-centered cubic or BCC crystal. We know the radius of a single chromium atom, and we're asked to find the density of chromium metal. So we have a couple of things here that we need to look up. First of all, the chromium weight from the periodic table. That is 51.996 grams per mole. We'll need that to find the mass of the unit cell. And then for the radius, here it's given in picometers. We need to know how radius relates to the edge length of the unit cell. And for a body-centered cubic or BCC crystal, the edge length is 4r over the square root of 3. We need to know that. And to find the density, that is mass over volume. And the property of density is one that applies no matter how much of the material you have. Whether you have a huge amount of chromium or a very small amount, the density is the same. And this applies all the way down to one single unit cell. If we know the mass and volume of one unit cell, we can find its density. So I'm going to break this up into two different things, finding the mass first and then the volume, and then using those to calculate the density. So for the mass of the unit cell, we know that this is a BCC crystal. And for body-centered cubic, in the unit cell, within the boundaries of the unit cell, there are two net atoms. In this case, two net chromium atoms in a unit cell. So to find the mass of the unit cell, we need to find the mass of two chromium atoms. So that's what I'm going to start with in my calculation. Then our weight on the periodic table is in grams per mole. To go from atoms to moles, we need to use Avogadro's number, and that is 6.022 times 10 to the 23rd. Atoms in 1 mole. And now we can go from moles to grams using the weight on the periodic table. And those calculations give us the mass of 1.727, 10 to the minus 22 grams. That is a very small mass, just the mass of two chromium atoms. And yep, that's the mass of our unit cell. Okay, now the volume of the unit cell. Again, we need to know that this is body-centered cubic, and we know the radius is 125 picometers. We know how the radius relates to the length, that one edge of the square of the unit cell. And the volume of this square would be length times width times height. They're all identical for our cube. So the volume is going to be the length cubed. We need to find the volume of the unit cell in cubic centimeters. And the units we're in right now are picometers. It will save you a lot of trouble if you convert out of picometers into centimeters first. So here, it's 10 to the minus 12 meters. And then from meters to centimeters is to the minus 2. So that gives us a radius of 1.25 times 10 to the minus 8 centimeters. And now I'll use that to find the edge length. And the edge length is 2.887 times 10 to the minus 8 centimeters. And then all we need to do is cube that to find the volume of the unit cell. Which becomes 2.406 times 10 to the negative 23rd. And now that's cubic centimeters. So that is the volume of our unit cell. Now I'm going to take the mass and the volume I found to find the density. So the mass was 1.727 to the minus 22 grams, and to the minus 23 cubic centimeters. This, when you divide them, gives us 7.18 grams per centimeter cubed. There, so that is the density of chromium, the density of a unit cell, and also the density of chromium metal. Thanks for watching.